Hello everyone, welcome to PRP Coding YouTube channel. I am Raveendran Pillai. In this session, I shall explain what is unit testing, the importance of unit testing, and how to unit test a .NET class library project using xUnit. So let's start. Unit testing is a software development practice that involves testing individual units or components of a software application in isolation. A unit is the smallest testable part of an application, usually a single function, method, procedure, or class. Together, these code units form a complete application, and if they don't work well individually, they definitely won't work well together. Unit testing ensures that each component of the software works correctly on its own before integrating it into the larger system. The essence of unit testing lies in its ability to meticulously scrutinize the most minor parts of an application, ensuring they work flawlessly on their own. This early stage testing is important for several reasons. Early bug detection. Unit testing catches bugs at the earliest stage of the development cycle. Identifying and fixing issues in small, isolated units prevent minor problems from escalating into more complex system-wide bugs. Code quality improvement. It encourages developers to write cleaner, more modular code. Since each unit must stand up to rigorous testing on its own, this leads to better structured, more maintainable code. Facilitates refactoring. With a suite of unit tests, developers can refactor code confidently. If a code change introduces a bug, it's quickly caught by the existing test. Documentation. Unit tests serve as a practical form of documentation. They demonstrate how each component is intended to work, making it easier for new team members to understand the code base. There are mainly three .NET unit testing frameworks: MSTest, NUnit, and xUnit. Here I am going to discuss about xUnit. In this session, I shall explain how to unit test a class library project using xUnit. For that, let me flip to Visual Studio. In the solution, you can see that I have created a class library project named Calculator Library. If I click on this project here, you can see that the target framework is set to .NET 8. Now, in this project, it contains a calculator class with 4 methods: add, subtract, multiply, and divide. All these 4 methods are taking 2 integer parameters as inputs, and it returns an integer. Now, let me go and unit test all these 4 methods inside this calculator class. For that, let me go and add an xUnit project in the solution. So right click on the solution, add new project, and here you can search for xUnit. Here you can see that this is the xUnit project. Here three xUnit projects are shown here. This is the C# version, this is the Visual Basic, and this is F#. So here we are going to select the C# version. So select that. Now let's name this project name as calculator library.unit test. So let me click next. Select the framework as .NET 8 and click create. Now here you can see that the .NET team has created some boilerplate code for the unit test project. It has added some files, global using.cs and unit test1.cs. Let me go and remove all these built-in classes. Let me delete it. And let's start everything from scratch. Okay, so now let me add a class in the xUnit project. For that, let me right click on this project, add class. Let me name it as calculator test. Okay, and let me add a method. I can say public void add test. Okay, I have given the name as add test. Yes. Now, let me open the text explorer. All the test methods will be visible in the text explorer. So here I can click on the test menu, select text explorer. Here, the add test method is not listed. That's because the xUnit project is unable to identify any test methods. xUnit consider methods decorated with fact attribute as unit test methods. All other methods are ignored. For that, let me switch to the calculator test.cs and decorate this add test with the fact attribute. So let me import the namespace. So this is coming from the xUnit NuGet package. So I can say using xUnit. Okay. So Here we got another error. So let me see that. Here it says that test classes must be public. Yes. So let me modify this internal modifier to public. Okay. So the error is gone. Now let me switch to the text explorer. This time here you can see that it has listed the calculated library.unit test. Okay. So let me expand that. So this the calculated test is our class. So inside that here we have added that method add test. So that's because we have decorated this add test method with the fact attribute. Similarly, let me go and add one more test method in the calculated test class. Okay, so let me go and add a method here. This time I have added a subtract test method and it is decorated with the fact attribute. Now let me go to the test explorer now. And here you can see that the add test and the subtract test methods are listed in the test explorer. Now let me go and run all these test methods. So here we have two tests. So here I can click on the run all test. Okay. So this first it will go and build the project and then it will go and run the test methods. And here you can see that both the tests got passed and here you can see a green tick over here. So that means the test got passed. Okay, so now I want to print the test method name in the test output window. So when I execute the test, I want to see the test name in the test detail summary over here. For that, let me switch to the calculated test.cs and let me add the code. Here I can say console.writeLine add test is executed. Similarly, in the subtract test, let me go and add. So let me copy this and replace this add test with subtract test is executed. Okay, so let me save this file and let me switch to the text explorer now. Now let me go and run this test. So let me click on the run all test. And here you can see that both the tests got executed. But we are unable to see the test method names in the test detail summary over here. Let me click on the subtract test also. Here also, it's not listed. That is because prior to xUnit version 2, console.writeLine works. If I click on this project over here, here you can see that here we are using xUnit version 2.4.2. From xUnit version 2 onwards, parallelization is turned on by default. Hence, console output capture mechanism was no longer appropriate. It is impossible to know which of the many tests that could be running in parallel were responsible for writing to those shared resources. So, is it possible to print messages in xUnit version 2 and above? Absolutely. xUnit tests have access to a special interface named iTestOutputHelper, which replaces the usage of console and similar mechanisms. For that, we need to inject the iTestOutputHelper interface in the constructor of calculated tests. So let me switch to the calculated test class and let me add a constructor here. For that, I can use the shortcut CTOR. And here we need to pass iTestOutputHelper. Okay, so I can say test output helper. So this iTestOutputHelper is coming from xUnit.abstractions namespace. So here, what I'm going to do here is I can say, so let me create a private read-only variable. Okay, so here I can say generate private read-only. So it has generated a read-only variable underscore test output helper, and I have assigned this test output helper to that. Now I can replace this console with underscore test output helper. Similarly, I can replace this console with underscore test output helper. Okay. So now let me switch to the test explorer and let me run this test. And here you can see that in the subtract test is executed, message is printed. Similarly, in the add test is executed, is printed in the test detail summary. Now, developers might be thinking, what magic is happening here? Just by adding an interface in the class constructor has solved the printing issue. So let me explain. If I pass iTestOutputHelper interface in the class constructor, what does that mean? It means that any instance of class that implements the iTestOutputHelper interface can be assigned to the variable testOutputHelper in the constructor. Now, the magic is that during runtime, the .NET Core framework will create an object of a class named testOutputHelper and assign it to this variable in the constructor. For that, let me add test output helper. So this is the class. Okay, so this is a class. Here you can see that it's a class xUnit.sdk.test output helper. Okay, so let me go to the definition of this class. If I click go to definition, here you can see that this class has implemented the iTest output helper interface. Now, if I search right line, so this is the method that we have used in our test. So here we have used underscore test output helper dot write line. So this write line is coming here. Okay, and the message is passed over here, and the logic inside this method will take care of printing the messages in the test output window. The next thing I would like to demonstrate is about the order of execution of tests in xUnit. For that, let me add a message to the calculator test constructor. So let me add the code here. So I have given constructor is executed. Now let me run the test in the test explorer. So let me switch to the test explorer tab and run all tests. Both the tests got passed. So now let me click on the add test. And here you can see that the order of execution is constructor is executed, add test is executed. So similarly, let me click on the subtract test. Here also the constructor is executed, subtract test is executed. In both the tests, constructor is invoked. So what does that mean? It means that each xUnit is running in different instance of calculator tests. That is the reason why the constructor is invoked twice here. xUnit class constructors are used to initialize test setup. This will help in avoiding code duplication in test methods. Similarly, it is possible to perform test cleanup. For that, in xUnit, we need to implement the iDisposable interface. So let me implement the iDisposable interface. Okay, so let me implement interface. And if I scroll down, let me close this. Here we have the dispose method over here. Currently, we don't have anything to clean up. For the time being, let me add a message here. So let me copy this message and let me paste it here and give it as dispose is executed. Okay. So now let me switch to the test explorer and run all this test. Okay, so let me click on run all test. Both the tests got passed, and here you can see that in add test, the order of execution is constructor is executed, add test is executed, then dispose is executed. Similarly, in subtract test also, constructor is executed, subtract test is executed, and dispose is executed. That's why I said constructor is used to initialize the tests and the dispose method is used to clean up the test. There are three main steps in unit testing. They are arrange, act, and assert. It's known as the AAA concept of unit testing. Now, let's discuss about the arrange. Arrange is the first step of a unit test. Here we will arrange the test. In other words, we will do the necessary setup of the test. To perform the test, we need to create an object of the targeted class. In our case, we need to create an object of the calculator class. For that, let me add the project reference. So let me click on the Solution Explorer, right click on the project, add, then select project reference and add this calculator library class. Okay, click OK. And now the first step is to create an object of the calculator class. So here I can say var calculator object under test is equal to new calculator. Okay, so here we have created the object of calculator. Now the second step is the act. This is the middle step of a unit test. In this step we will execute the test. In other words, we will do the actual unit testing and the result will be obtained from the test application. Basically, we will call the targeted function in this step using the object that we created in the previous step. So here we have created the calculator object under test. So in our case, we need to go and call the add method. So here I can say int actual result is equal to, let's say, calculator object under test dot add, and here we can pass two numbers. So I'm going to pass 5 and 5, 5 comma 5. Okay. So now the last step is the assert. In this step, we will check and verify the actual result and the expected result. So here we know that, let me say int expected result is equal to 10. We know that 5 plus 5 is 10. Okay. And here we need to check whether the actual result and the expected results are the same. For that, I can say assert dot equal expected result comma actual result. So what I will do now is let me go and remove this uh, test output helper dot write line methods. It's no longer required. So let me remove this as well. Let me remove all these things. Let me remove this dispose method also, because we are not going to use this dispose method in this demo. Okay, let me remove this idisposable interface. Okay, so now let me go to the test explorer and run the test. Okay, so this is the add test. So let me click on run all test. Okay, both the tests got succeeded, and if I click on the add test here, you can see that okay, it is passed. Now let me go to the solution explorer. Let me go to the calculator and let me make a modification here. So instead of plus, the developer accidentally used star here. Okay, so it's a multiplication. Okay, so now let me go to the test explorer now and let me run this. Immediately there is an error. The add test got failed. So here we got the error, the message assert dot equals failure, expected 10 and actual is 25. That makes sense, right? 5 into 5 is 25. So unit test helped in early bug detection. With a suite of unit tests, developers can refactor code confidently. If a code change introduces a bug, it's quickly caught by the existing tests. Now let me go to the calculator.cs and let me make this modification and let me give it as plus here. Okay. Now let me go and add the test for subtract, multiply, and divide. Okay. So let me copy this code here. Let me copy this to C, paste it here, and here I'm going to call dot subtract by 5, and here we know that the result is 0. Okay. So similarly, let me go and let me copy this whole code, paste it here. So this time it is multiply test. Okay, and here I will be calling dot multiply, and here we know it is 25. And similarly, we have one more code, one more method to test, that is the divide test. Okay, so let me go it as divide test. Okay, so let me make it as dot divide, sorry, divide by 5, and here we know that the expected result is 1. Okay, that's it. Yeah, I can go and remove this I test output helper also. This is not required. Okay, so now let me go and run all the test here. Now in the test explorer, here you can see that now it has showing add test, divide test, multiply test, and subtract test. Okay, so now let me go and run all the test here. So let me click on run all test. And here you can see that all the tests got passed. So this is an introduction to xUnit testing in .NET. If you find this video helpful, then please like, share, and subscribe to my YouTube channel and stay tuned for the next unit testing episode. Thank you.